All right, let's have a look at 134, question number 1. It says, refer to example 3.3, which, if you remember, this was a canoe that was being pulled by two different people, person A and person B. Person A is pulling it now at an angle of 40 degrees. Person B is pulling it at an angle of 20 degrees. They're both pulling it with a force of 60 newtons. So I'm going to call FA 60 newtons at 40 degrees, and I'm going to say FB is 60 newtons at 20 degrees. Now it does say that it's a frictionless surface, so that's a good thing. We don't have to worry about friction. If there was friction, then it would act in the opposite direction to the net force here. Now, you want to find the net force. What does net mean, the word net? It means total, right. The word net means total. So we want to find the total force here. And we want to find a total of anything, you add them together. But it's not just as simple as saying 60 plus 60 is equal to 120. Well, we're adding these together, but not in the old-fashioned 60 plus 60 equals 120 way of adding. Why not? Why can't we do that? If I want to find the total force, why can't I just say it's 120? Yeah, Liam? Okay. So there's different directions? So their direction matters? Yes, it does. And it matters because these are vector quantities. When we're adding vectors, we've got to make sure we take into account the direction and not just say 60 plus 60 is equal to 120. All right, so we see that up on the board here. We know we're going to have to deal with direction. What is it that jumps out at you in terms of direction with this question? Something should jump out at you. Yeah, in fact, there's two of them, right? Two funny angles, neither one of which we like. I'm going to get rid of this, actually, just to create a little bit more space. So let's take those off to the side and let's deal with them. We've got an angle of 40 degrees, 60 newtons. Looks like this. Let's break it up into x components and y components. This is x, this is y. Let's say cosine 40 degrees is equal to x over 60. I'm using cosine because x is the adjacent side. Right? The adjacent side, I have the hypotenuse. Cosine 40 degrees is equal to x over 60. X ends up being equal to, we get 45.9627. There's no firm rule on where we should round that when it's not a final answer. Ideally, we keep an unlimited number of decimal places, but realistically, you got to round it somewhere. Use your rule of thumb is 4 or 5 decimal places, and then round it. Let's go sine 40 degrees is equal to y over 60, or opposite over 60. 60 times sine 40 gives me 38.5673. And that's going to be newtons as well. All right, good. There's one of them off to the side, dealt with. Let's redraw this here. Let's say we've got 45 this way, and I've got 45.9627 that way, that is, and I've got 38.5673 this way. All right, let's deal with the other one now. The other one says we've got 60 newtons at 20 degrees. Here's x, here's y. Which side of the triangle is x this time? Abby, which side of the triangle am I looking for this time when I'm solving for x? Is it opposite or adjacent? Yeah, so I'm going to use the cosine function again. Right? Cosine 20 degrees is equal to adjacent over the hypotenuse. That's 60 as well. So we got, what do we got? 60 cosine 20 gives me 3816. And then we'll say sine 60 degrees, sine 20 degrees is equal to y over 60. 60 times sine 20 gives me 20.5212. Let's kind of box that off over there as well, because it's kind of an aside thing, right? Now, whether you're solving for those x and y components using sine and cos, like I do, or whether you're using the sine law or cosine law or whatever it is that you're doing, okay, we should end up with the same numbers for x and y components. Let's replace the x and y now, or let's replace that 60 with the x and y components now. We've got 56.3816, and then we've got 20.5212. I didn't draw those to scale very well, because that 20 should be about half as long as the 38, right? But good enough. So now we got to go into, what do we got to do now? 50, just add all these up, 45. We said we got to account for direction, right? We've done that. So 45 plus 38 plus 56 plus 20. Is that what I do? The 20 should be negative, yeah. But it's still not as simple as saying 45 plus 56 is about 100, 156, 136. So what am I going to do? Yeah, I've got to go x and y components. Good. Now, Maddie, what's the x component of the first one? Let's make the green one my first one, okay? So just so we're all on the same page, green one's the first one. What's the x component? 45.9627. Good. What's the y component of the first one? Yeah, now some people are going to say 45 and 0, and then 0 and 38, right? And kind of make it two separate vectors here. Is that okay? Sure it is. We see this as 4 vectors now. We changed 2 vectors into 4 vectors. You can list 4 different vectors. Or you can kind of in the back of your mind say, okay, look, I know those green ones are really the same vector, an x and y component, so I'm just going to do it in kind of one step. 45.96, and we've got 38.5673. Vector 2, the x component is 56.3816, and the y component is what? What's the y component, Ireland, of this one going to be? This blue one. Good. Negative 20.5212. Good. Not only is it important to get the right vector, it's important to recognize that it's negative as well. Seems like such a small thing, but like if you mess up on the negative, okay, then everything else is wrong. And you know you can still get some good part marks for that, but obviously we want to get it correct. Okay, let's add these up here now. 45.96 plus 56.38 gives me 102.3442. And then on the other one we got 38.56 plus negative 20 gives me 18.0460. And now what? Well, 102 plus 18 is 118. Is that right? Is that right? No, it's not. You're right. You're correct. Okay, Jen, what am I going to do if 102 plus 18 is not 118 or 120? Do I just add these two up now? 102 plus 18 gives me 120? No. So what do I do with them? Kyle? I do add them up, right? But Kyle, how do I add them up? Yeah. 102 goes this way, and 18 goes this way. And then the resultant vector goes right here. Where am I going to label the angle? Position 1, 2, or 3? 1, 2, 3. 3. We're going to find the value of r by the Pythagorean Theorem. What do we get there? 18 squared plus 102 squared. Square root that. 103.9, or we're going to make that 104. And theta would be the inverse tan of opposite. What's the opposite side here? Is it 102 or 18? 18. Yeah, the inverse tan of 18 over adjacent, which is 102. Gives me 10 degrees. I get exactly 10 degrees. How do I express that? 10 degrees watt of what? 10 degrees what of what? Liam, what do you think there? 10 degrees south of west? 10 degrees what? Which way am I going here first? To get to this point, where do I go? Which way is this? Yeah, to the right or to the east. And then after the east, I go, or north. So I went north after east, or I went north of east. So we're going to say that's 10 degrees north of east. Is that okay? Okay, is Phil okay with that? Yeah? All right, I'd like everybody to have a look at this question up on the board right now. We'll do this together in a few minutes, but I'd like to give you 4 or 5 minutes yourself to take a look at it and see what you can do with it first. So let's do that now. Do what you can. Remember the funny angle, how you deal with the funny angle, the x and y components, and so on. And then we'll take a look at it as a group when you're finished. All right, my question says, find the net force acting on the object in the diagram below. Do not ever, when you've got forces acting on more than one axis, this is x, this is y, when you've got forces acting on more than one, don't ever just say, oh, 20 plus 20 plus 20 is equal to 60. That never will work, okay? It'll never be the answer, 0% of the time. What we've got to do is deal with x and y components. And to do that, we've first got to deal with that 20 Newton force, take it off to the side, put it out of its misery because we don't like funny angles. Let's label this as x and label this one as y. We're trying to find the x component first, or the x side of this triangle first. Bree, which side of the triangle is that? Is that opposite, adjacent, or hypotenuse? The x side. Yeah, so if we have adjacent, or if we're looking for adjacent, we have hypotenuse, we're going to use which trig function? Right? So cosine 30 degrees is equal to x over 20. X ends up being equal to, I believe it's 17.3205. Is that right? Newtons. And the y component, we're going to say sine 30 degrees. It's the other one. Is equal to opposite of hypotenuse. Y ends up being equal to exactly 10 newtons there. So let's just box that off. And then let's go over here and do our x and y components. You know what? Before we do that, actually, let's replace that angle and everything in there with two vectors. We've got 17 We've got 17.3205, and then we've got 10 newtons. That should be down. All right, let's call this one number 1, this one number 2, and this one number 3. What's the x component of the first one? Taylor, what's the x component of the first one there? 20? No. Oh, you know what? You're using this one. Okay, never mind. With the way that I have it numbered, the x component of this first one is 0, right? Yeah, I mean, you do it in the opposite order, and that's absolutely fine, right? I just want to be consistent with the way that I have it drawn here. So we're going to say that's 0, and the y component would be 20. Now, Taylor, the x component of the second one right here would be what? 20, good. And the y component would be 0, good. And the x component of the third one, Janae, would be what? 17.3205, is that right? But negative, yeah. And the y component would be negative 10. Add these up. 20 plus negative 17. $2.6795. And this is going to be just 10 newtons. So we're going to say 2.67, 10 newtons. And then our resultant vector goes from start to finish. R is equal to the square root of 2.67 squared plus 10 squared. 10.35, which actually rounds out to be 10 newtons. And the angle is going to be the inverse tan function of opposite over adjacent, the inverse tan of 10 over 2.65. Or 2.67. 75 degrees. And that would be 75 degrees what of what? So 75 degrees what of what? Which way do we go first here? East, then north after east, or right. 75 degrees north of east. If you had to draw on that opposite, you would have gotten 15 degrees east of north, which would have been correct. Okay? Good? All right, I want to show you, just for a second here, the difference between two types of questions that we've done recently now. The question that you're going to get on tomorrow's quiz, which is going to look something like this. It's a wagon type problem. Okay, we're pulling it with a force of whatever. There's a force of friction of whatever, and this wagon just moves along the horizontal surface, along the ground. Versus this problem that we've been doing today and at the end of the day on Tuesday, where we've got three forces acting in whatever directions, and I'm looking for the net force. Okay? Understand that although there are x and y components of both of them, this one ends up being just the x. The reason for that is because although we have a force of gravity acting down here and a normal force acting up, the y component of the applied force combined with the normal force will end up canceling out with the force of gravity. So these ones end up canceling each other out. The only thing that I have left here in this question would be this. So the net force becomes equal to FF plus Fx, the x component of the applied force. I can do that here. I can say F net is equal to FF plus Fx without doing x and y components because the y components ended up canceling in these wagon type problems. But in these, we'll call them Halloween candy problems because I think the first example we did involved, no, I guess that was another one, but that's okay. We'll still call them Halloween candy problems. We're pulling on this Halloween bag from all kinds of different directions. Okay? Forces don't cancel each other out, or at least most times they don't cancel each other out. So that's when we have to add up all the x components, add up all the y components, do a new triangle, and then do the Pythagorean theorem and the inverse tan function. Does it make sense, the difference here? Yes? All right. Do we need to do another example of either one of these? This is your quiz tomorrow. This will be next week sometime. Another example of this? Yeah, absolutely, absolutely. Okay, so let's say we got this wagon, and we're pulling on this wagon, or, hey, what would be another situation where you'd apply a force at an angle, but the object would move horizontally? I just thought of this one, actually. Something that I was planning to do, well, for the past 2 weeks, and then never got around to it, and now it's too late. My lawnmower, right? My lawnmower, except that with the lawnmower, I'm not pulling at an angle. What am I doing? I'm pushing down at an angle. And that doesn't make any difference, right? We'll still call that a wagon type problem because we're pulling or pushing, we're applying the force at an angle. So let's do that this time. Let's make this a lawnmower. Let's say we're pushing down on the lawnmower at an angle of, let's say, 40 degrees. And let's say I'm pushing that lawnmower that has a mass of 20 kilograms with a force, we'll call it an applied force, of 100 newtons. Now, there is a resistive force acting here. It's a good question. There is a resistive force acting here. Let's say that friction is going to act to oppose the motion. And let's make that a value of 15 newtons. And let's say that there's going to be a force of resistance with the grass, because the grass is kind of long and shaggy. Let's make that force 10 newtons. We'll just call it Fg. No, let's not call it Fg. Why do I not want to call it Fg? We don't want to get it mixed up with gravity, right? Let's call it FR, the force of resistance for the grass of, let's make it 10 newtons here. All right? We want to find the acceleration of this lawnmower. Give you a few minutes to do that now. So here's our question. 100 newtons being pushed down on this lawnmower, force of friction backwards, force of resistance from the grass backwards, and our angle is 40 degrees here. Do we have any more forces acting on this? There's no other forces that are going to contribute to the motion here, right? But we do have more forces. What are they? Okay, so Fg and Fn. Now in these wagon problems, Fg ends up being bigger than Fn, correct? Is that right? And that's because the y component of the applied force combined with the normal force give me gravity, right, Kyle? No? What's wrong? Yeah. Now, not that it really matters for what you had to do with this question, but in this question, gravity is smaller than the normal force. Why? Because the applied force, the y component, is downward. So the y component of this force combined with gravity would be equal to the normal force. Does that make sense? Like, it doesn't affect how you do this question, but in the event that you needed to find the normal force, it would affect it. So in this case, to find Fn or Fy or Fg, we'd say Fn, the upward force, is equal to Fg plus Fy, the two downward forces. Remember, in the typical wagon problem, where we were pulling up at an angle like in a real wagon, then we said the force of gravity equaled the y component upward plus the normal force upward. Bottom line is, all the upward force has to equal all the downward force. And in this case, we have two downwards instead of two upwards. All right. In the end here, that cancels with that and with that, so it doesn't really matter. What do we got left? Well, we've got this, and we've got this. The x component of that applied force, and we've got the force of friction and the force of resistance. So let's get Fx. Let's get Fx. Abby, how do we get the value of Fx there, the x component of that 100 newtons? Good. We're going to say cosine 40 degrees is equal to adjacent, Fx, over the hypotenuse, 100. Abby, do you happen to have the number there? 100 times cosine 40? 76.604 newtons. Okay, good. And now what do we do next? What do we do now? Sydney, what do we do now? Yep. F net is equal to what? Yep. Fx plus Ff plus Fr. And then we say m times a, 20 times the acceleration equals 76.604 plus 15 plus 10, right? Right, Liam, no? What's wrong? Okay, the 15 and the 10 could be negative. Oh, you know what? Actually, no, that's, if I look closer at it, I was going to say I was going to do it differently. That you were correct, but that I was going to do it differently. But as I look closer, no, that's the way I would do it, actually. I'm used to seeing the forces to the right on the right-hand side and the forces to the left on the left-hand side, right? And we've got that reversed this time. Okay, so yeah, I am going to make those two resistive forces negative. Now, I could have done it the other way around, but I do think that you're right. I think that makes the most sense there. So let's get the right-hand side there. We're going to say 76.604. Subtract 15, subtract 10, gives me 51 on the right-hand side. Divide that by 20, and the acceleration of this lawnmower ends up being 2.58 or 2.6 meters per second squared.